Hello, ladies and gentlemen. We are getting ready to go into our second day of graphing sine functions. Now, I'm not going to do all of these, but I am going to jump in and do several where different things are changing in our graph. But I thought it would be a good time to rewind back to yesterday for a minute, okay? To rewind back to what a plain old regular sine graph looks like. So we're going to pull this up for a second. And we're going to chat a little bit about where the numbers come from and kind of the pattern that's involved in this. So yesterday, you should have gotten, if you didn't, go find one over in the folder area, something like this. It says parent points for radian angle measures. Now, I'm not going to write on it because, well, we kind of change this as we go. If you have a pencil, I suppose you could. But what we're going to do here is these, okay, are my angle measures. Okay, I can even do this if I want to on there. What I'm going to do is I'm going to go through with you what the sine values for those are. And so yesterday we talked about how sine typically starts at 0. Then it goes up to the maximum, back to 0, down to the minimum. Oh, shoot, I'm running out of room. Hang on just a second here. And then back to 0. Okay, those are my parent points, my base points for my sine. So, when I have those, 0, 1, because we're always going to have 5 points we use. Oh dear, sticky. 0, down to -1, and back to 0. Now, you'll notice on the one that I did, as I get my curve in here, I don't have all these labeled. So, because I wanted to show you again where these values are coming from. If I wasn't given those, or if it changes, here's how this works. We always know that with a sine graph, the period we talked about yesterday is 2 pi to complete one regular cycle of sine. You see that here. But I need to label the values in between, not just where I start and where I end. So this is where we use a little common sense. Okay? What's right in between 0 and 2? 1. So 1 pi. What's, right in the middle of 0 and 1? Well, half, right? Now we're not going to put 0.5. It's like we're writing a half, except we're using pi instead of the 1. Okay, so this is 1 pi over 2. This is 2 pi over 2, because every line after it now, we're just going to add another pi to it. So this would be 3 pi over 2. And this one would be 4 pi over 2. You're like, why don't you just write them that way? Because they reduce. 2 divided by 2 cancels. Gets me 1. 4 divided by 2 is 2. So anytime you're graphing one of these, if we figure out the first value, we can just keep adding one of those all the way through, and that might come in handy a little bit later. So this is my typical sine graph. We might refer back to this as we go through. We'll see. So I look and I say, okay, what's the first one we got on here? We got y equals 3 sine of x. Okay? So this is what's called my amplitude. This is my A value. So when I'm doing a sine, or once we get to tomorrow, a cosine graph, I have a feeling many of us are going to kind of just draw ourselves a little chart here, and that's okay. It's not a bad idea. We've got our parent points here. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then we have our sine values. 0, 1, 0, -1, and 0. Okay. So now what happens with this 3? What's this 3 going to change? Well, here's the answer. Whenever we have an A value, the A value is going to change the sine part of our value. Okay? How high up or how low it goes. So we're going to multiply all of our sine values by 3. Now, you may get to a point where you're comfortable enough not to do it in a chart like this, where you just kind of do it in your head, or you just have the generic chart and you do that in your head, and that's A-okay. But I would say for the time being, it's in your best interest to get this set up this way. So these will be our magic values. And these are the sine functions that we'll be using, the angle measures. So I already see that whoever did this, me, was nice. Okay, these are on here for me. And so now I usually will label these just to make sure. And then I just follow. 0, 0. Okay, at pi over 2, we're going to go up to 3. At pi, we're back to 0. At 3 pi over 2, we're down to negative 3. And at 2 pi, we're back to 0. And so the other thing I want to discuss a little bit here is I'm trying to draw this as nicely as I can, is this concept of something called a center line. Now, for the ones we're doing, this center line is just going to be, it just literally means, hey, if I was to draw in a little dotted line in the middle of my graph, where would it be? And so typically on sine graphs, wherever your first point is, it's going to go straight through here. So you've got sort of a reflection of your graph both above and below it. Just something, again, we're getting a little bit of an intro for. And so if I keep looking through these, whatever that value in front of my sine is, we're going to multiply all the sine values. So the only thing else I'm going to mention on this first page is sometimes people look at this one. We're going to rewrite this. If you just see a negative sign or something there, remember, it's like having a negative 1. Okay, if I get a negative, my graph may not look quite the same. And we'll see another one where there's a negative a little later in. So that's why I'm not worried about doing this one here. But same process, just we'd multiply through here by negative 1 instead and make our graph. So that's what our A value does. So then we get to B. So let's say, which one? Let's do this one. So y equals sine of 4x. I don't see a number in front of my sine, so I don't have an amplitude change this time. So we'll go ahead. We'll get in. Again, just have your little mini help sheet available. So now this time I get a little something different going on. This time I've got a number over here in front of my angle. That's my B value. Now B value has to do with the period of our function. So that is going to change our angle measure. So to find our period, how long it takes for one of my cycles to complete, we have this little mini formula called 2 pi over B. So, since my B value here is 4, in this case it would be 2 pi over 4. And if you can reduce the fractions, as always, you should. And again, it's just the coefficients I'm looking at. 2 over 4 reduces to 1/2, or pi over 2. So now here's where life gets a little more, and no, it's not time to go. Life gets a little more interesting. Okay, and I'll show you how we can kind of adjust with this. This means my entire sine graph is going to do its total cycle between these two spots. Okay, we're going to get really squished in here. So you're like, well, how do I get the values, that go in here? Which is a good question. Here's how we do it. Whatever our B value was, in this case it's 4, we can always multiply all of our values by 1 over B. Okay? In other words, I'm going to multiply all of these by 1 over 4. Every single one. So once I do that, 0 times a fourth is 0. Okay, multiply across. Pi times 1 is pi. Over 2 times 4 is 8. pi times 1 is pi over 4. 3 times 1 is 3 pi. 2 times 4 is 8. And then here comes the big one. 2 times 1 is 2 pi over 4, but 2 over 4 reduces to 1/2 or pi over 2. And you're like, well, why was that the big one? Because if I did my math right, this last one I get will be the same answer that I got when I calculated my period. That's how I know I did it right. And if you get into these graphs and you're like, well, I don't see any of the values here except pi over 2, so what do you want me to do? I know this is going to be kind of sneaky, but we're going to do it anyway. If your values change here, we're just going to kind of scratch these out. I tried to find something that were blank, but I wasn't having good success with that. And so what we're going to do is we're just going to replace them with these. So pi over 8, pi over 4, 3 pi over 8, pi over 2. So you're like, okay, so what about these? Do we multiply them by something again? Not unless there's a number out front. So this time, what you see right here, do I have a highlighter? I do. What I see right here is what I'm graphing. So at 0, I'm going to be at 0. At pi over 8, I'm going to be up at 1. At pi over 4, I'm going to be back to 0. At 3 pi over 8, I'm going to be down to -1. And at pi over 2, we're back to 0. And that looks... Whoops, I almost got a little too crazy there. And I get my graph in. Okay? So remember, first page, if the number's in front, if it's an A, it stretches my graph. And if it's like this, even though we scratch these out, it's going to kind of shrink my graph this way. Or it could expand it too, depending on what my B value is. So here's what we're going to do. Now we're going to find another one that does both. So let's see here. Ooh, that looks interesting. So let's see here. Let's actually do the very last one on this side here. I don't think, yep, that's the end. So we're going to take a look at this one on the bottom. Nope, still no time to go. So I look at this and I go, okay, my A value is -3. My B value is 0.5, or we could call it a half if you want to do that. And so this time, when I make my chart, notice I'm leaving myself a little bit of room on these because we never know when we may have a little bit of math work that we need to do. Okay, so I get my base values. Now I try to remember back as best I can. Okay, what value changes what? The sign, this part, is changed by when I multiply it by A. So since my A is -3, I'm going to multiply all of these by -3. Bells, bells, bells. So we multiply these out. Okay. So those will be my up and down values when I get to my graphing piece here. As long as I got these base values, these first values, shouldn't be too bad at all. So then I look at this one and I go, okay. So then this is the one that B changes. So remember, B helps me figure out my period. 2 pi over B. 2 pi over 0.5. Now some of you might want to go to a calculator for some of this. And I also want to do it with the calculator just so you can see. We're not going to put the pi in. Ooh, bright. Okay, just the 2 divided by 0.5. Now if I'd have gotten something that's a fraction, of course I'd do math enter enter if I got a decimal. But here I got 4 because when we divide by a fraction, we get a smaller value. So remember, that number is important because if I do my math right, my last one should end up being 4 pi. So you're like, well, wait a minute. How do you divide by, ooh, Harty, this is going to be kind of nasty. Because you're like, doesn't that say that you multiply by 1 divided by b? Yep. Well, what's that going to be? I don't know. Let's look. What's 1 divided by 0.5? 2. Okay. So we're going to multiply all of these by 2. Or 2 over 1 maybe is a good idea. Whatever that b value is that you have, we're always going to flip it. So maybe in this case, it even would have been better if I'd have written that as 1/2 instead. And then I'd have known, oh, it's 2 over 1 that I'm multiplying by. So what's that mean these values are going to be? What are the new values for my x-axis going to be? 0. So I got 2 pi over 2. Maybe I do a little side work here too, which is just pi. Pi times 2 is 2 pi. 3 times 2 is 6 pi divided by 2. 3 pi. Oh, here's the big one. 2 pi times 2 is 4 pi. If those match, hot dog, I probably have done this right. So now I'm ready to graph. So once again, I really don't mind that you do this. We'll just kind of scratch these guys out, and we're going to use these. So there's 0, pi, 2 pi, 3 pi, 4 pi. And now I'm ready. 0, 0, pi, -3, 2 pi, 0, 3 pi, 3, and 4 pi back to 0. And you may notice something. You're like, hey, this doesn't look like those other sine graphs I've been doing. And you'd be right. Because of that negative a value, it flipped my graph. Instead of going up and then down and up, it did just the opposite. Okay? So between yesterday and today, and remembering to use your parent points card here, try out some of the other ones. We're going to be staying in graphing tomorrow. We're going to go to a cosine graph, but the regular rules are going to stay the same. But get that practice in to get yourself a good basis of understanding with this, and we'll see you tomorrow.